Before we start some math, let's just clear up a little myth. No, complementary events are not those days when somebody said, "Hey, I really like your hat," or "You look like you've lost some weight." Although those are pretty nice events, but in math, they're not complementary. Instead, you can think of complementary events as kind of the opposite of what you're actually looking at. So if you have a pizza on a table with 8 slices and I take away 2 slices, the complementary event is leaving 6 slices behind. I've taken 2 away. That's the event we're looking at. But the complementary event is like it's like the opposite. So 2 slices removed, while the complementary event means 6 slices left behind. Or another way to look at it, let's say you watch TV for 4 hours a day. Well, the complementary event of that is you didn't watch TV for 20 hours out of the day. Actually, that sounds a lot better. So the complement is the opposite. So with that in mind, let's have a look at our problem. A standard deck of cards has 52 cards. In A, what is the probability of drawing an ace from the shuffled deck of cards? And then in B, this is where the complement comes in. What is the probability of drawing anything but an ace? All right, let's get started with A. Do you remember the rule for finding probability? Well, we're building a fraction, but do you remember what's on top and what's on the bottom? Let's review that. The fractions that you build always look like this. On the top, we have the number of events being watched divided by the number of possible events there are. So for A, the number of events being watched, what is that? Well, we're looking for the probability of drawing an ace. So we're watching for aces. Now, how many aces are in a deck of cards? Well, there's the clubs, spades, diamonds, and hearts. That's 4. There's 4 suits in a deck of cards. And there's an ace for each suit. So there are 4 aces. Now, the number of possible events. Well, how many cards could you possibly take out of the deck at random? There's 52 cards in the deck, so that's the possible events. There's 52 possible outcomes when you reach in and grab a card at random. So 4 out of 52. So we should show that by saying the probability of an ace is 4 out of 52. 4 possible aces out of a deck of 52 cards. Now, I'm not quite done. Can I reduce this? Well, yeah, I can. 4 divides 52 13 times. So that'll reduce to 1 over 13. And that's my answer for A. All right, let's tackle B. The trick for using the complement when probability questions is knowing that the rules for probability say that all possible outcomes must add up to 1. And when you reach into a deck of cards, there's only 2 possible outcomes in this question. Either you get an ace or you don't get an ace. So both of those must add up to 1. Here's how we can write the complement of getting an ace. The probability of not ace, in other words, probability of not getting an ace, is equal to all possible outcomes, which is 1, and we subtract from that the possibility or probability of getting an ace. And we know the probability of getting an ace. We found it in part A. So the probability of not getting an ace is 1 minus 1 over 13. And now it becomes a bit of fraction math. We have to subtract 2 fractions. Since there's a 13 on the bottom, I need to use that as my common denominator. To turn this 1 into something with a 13 on the bottom, I'm going to multiply the top and bottom by 13, and it's going to look like this. 13 over 13 is equal to 1 over 13. And now it becomes much easier. 13 minus 1 is 12. So the probability of not getting an ace in a deck of cards is exactly 12 over 13. All right, so remember that trick. Whenever you're asked to find the probability of something not happen, usually it's easier to take a step backwards and find the probability of it actually happening. Then we take 1 and then subtract the answer that we just got, and that'll tell us the probability of something not happening. And we subtract the probability of it happening from 1 because the rules say that all things, all possible outcomes in probability must add up to 1. And with that in mind, let's get you to practice finding the probability of complementary events. Here's your question. A bag contains 12 identically shaped blocks, 3 of which are red, and the remainder are green. The bag is well shaken, and a single block is drawn. In A, what is the probability that the block is red? In B, what's the probability that the block is not red? Remember that tip for finding things that are not. Okay, try that one now, and I'll post a solution when you're ready. For part A, the probability of reaching into the bag and getting a red block was found to be 3 over 12, and reduce that to 1 over 4. For B, the probability of reaching into the bag and not getting a red block was found to be 3 over 4. And we did that by doing 1 minus our answer for part A, which was 1 over 4. So 3 over 4.